Okay, so in this video, we're looking at a mixture of transformations. Okay, so we'll go through two very typical exam questions where you need to perform multiple transformations, okay? And often, right, so the question here is talking about we've got a triangle P, and the triangle is reflected, first of all, in the line x equals to -1, and then reflected in the line y is equal to 1 to give a new triangle Q. Okay, and they often say, right, describe fully this single transformation that gets from P to Q. That's the same thing as doing both of those transformations. So the easiest thing to do here is just to get stuck into it and look at each of the transformations at a time. So the first one, we're doing a reflection in the line x equals to -1. So let's begin by doing that one first of all. Right, so your line x equals to -1 is going to go through the x-axis at the point -1. Okay, and then this is where you need to choose a vertice, like up here, which is, there we go, and you count along 1, 2 squares to that line, which means you've got to go 1, 2 squares across, and then go and mark in that point, which is going to go over here. And then you choose another vertice, like this bottom left one down here. Okay, and you count along again 1, 2 squares, so you go 1, 2 squares again across to give us this point here. And last but not least, we've got this point here, and then we're counting along by 1, 2, 3, 4 squares, so 1, 2, 3, 4 squares to give us this point over here. And let's join it all up. So let's join these all together. So we've got this, we've then got this, and we've got this. Okay, so I've now performed the first transformation, right? So I've got a mark straight away in the exam just for doing that. I've reflected the shape along line x equals to -1, but now I've got to reflect it again, this new red shape. I've got to reflect it in the line y is equal to 1. Okay, so let's go and do this in a different color. And you know what? I don't know why that wasn't supposed to be red. Let's keep that in yellow, otherwise it will get a bit confusing maybe. Okay, I'm now going to reflect along the line y is equal to 1. Okay, well, the y-axis this time going through the point 1. This here is your line. Y is equal to 1, and really I should have labelled on the first one. Right, that is the line x is equal to -1 to keep it really clear. Okay, so now I've got to go and reflect this red shape here along this green line y equals to 1, but in the same way, I choose a point, I count down to that line, which is 1 point, so then 1 point down again, and I make sure I go and mark it in. Okay, so it's going to be going here. And then again, right, I choose another point, so this point here, I go down by 1, so let's go and plug that in, which is going to be here. And then last but not least, I choose my last point, which is here. I go down by 1, 2, 3, 4, 5. So down by 1, 2, 3, 4, 5, which is going to go to, sorry, 1, 2, 3, 4, 5, down to, 1, 2, 3, 4, 5, down to this point here. And then I join it all together using some straight lines, using my ruler. There we go, there we go, and there we go. Okay, so now, right, I've done the first reflection in the line x equals to -1 to get me this red shape here, and then reflected this red shape along the line y is equal to 1 to give me this green shape, which I've got here, okay, which is now my new triangle Q. So let's go and draw this in here, label it Q. And the question is saying, right, describe fully the single transformation to get from triangle P, so to get from this one up here, down to triangle Q. Right, just by looking at it, it could be 1 or 4 transformations, right? It could be either a translation, but could it be that one from the previous video? That is either moving across, up and down, and sideways, but the shape is the same. Well, it can't be that one. Could it be a reflection? Well, it could be. It's kind of like the shape's not the same, so potentially it could be that one. Could it be an enlargement, which is either getting bigger or smaller? Well, definitely not that one, because it's the same size. And then the final one is it could be a rotation, which looks like the one that it could be. Okay, so it looks like it could be a rotation, right? So either maybe a reflection, but probably going to be a rotation. So straight away, right, let's rule out translation and enlargement. But straight away, we get a mark for saying that it's going to be a rotation. And unfortunately, this one's going to be a bit tricky because I haven't got any tracing paper. Okay, but what you'd have to do now is, right, you'd have to imagine, right, I can sort of roughly draw out. You'd have to get your tracing paper, draw out you get your paper over the shape, and then you would trace in this shape here, triangle P, okay, and then you would try and rotate your paper around. I can't do it on the screen, unfortunately, but you would choose a point, like on the previous video, and you would rotate your paper around, and you would see that if you rotated the shape about the point minus 1, 1, and let's get rid of all those lines there so we don't get confused. So if you rotated the shape P about the point minus 1, 1, which is actually happens to be this point here, okay, and that's going to write it in. So if we rotated, the shape 180 degrees, so rotated 180 degrees about the center of rotation minus 1 to 1, okay, we would actually get from the shape P to the shape Q. So instead of doing both reflections, you can do just one transformation, which is a rotation of shape P 180 degrees about the point minus 1, 1, so about this point here. Okay, really, it's hard to do on this computer, but you need to get trace paper and show that visually, but that would give you what you wanted. Okay, so that can go down there in our answer box. Okay, good. Let's move on. Okay, another exam style question. It is an exam question. So part A is saying, right, describe fully the single transformation that maps triangle A onto triangle B to begin with. I want to get from triangle A to triangle B. Again, let's go through our transformations. Could it be a translation? No, because the shape's kind of been tilted a bit, hasn't it? So it can't be that. Could it be an enlargement? No, because the shape is the same size. It's just kind of been rotated, or either reflected. Okay? Well, actually, this one here is, to me, and it's quite a typical one that they like to go for in exams. I'm going to assume, because it's one they like to go for, it's going to be a reflection in the line y is equal to x. That is one that they quite like to go for. So let's try that. That's my line y is equal to x. And remember, when we check a reflection diagonally, we choose a point like this one up here, and we count diagonally. So that's 1, 2, 3, 2.5 squares. So half, 1, 2 squares. Good, that one works. Let's choose another vertice like here, and it's going to be 1, 2, 3.5 squares. Half, 1, 2, 3. Good, so it works. And your last vertice, we're going 1, 2, 1, 2. So perfect, right? So in this case, the single transformation, right, is going to be a reflection. So a reflection in the line, or you could just say line, but in the line y is equal to x, and that is it for the first mark. Okay, that is your answer there. Reflection in the line y is equal to x. Okay, then below we've got triangle A can also be mapped onto triangle B using a combination of transformations. A transformation T followed by a reflection in the line x is equal to 0. Describe fully the transformation T. Okay, so on my screen it's kind of cut out, but sorry, let's read that again. Right, so the triangle A can be mapped onto triangle B, so this can be put onto triangle B, right? So from here to here, using a combination of two transformations. So first of all, some sort of transformation, which I don't know what that is. I'm trying to find that. Followed by a reflection in the line x is equal to 0. Well, let's go and do that one first, because we can do that one. A reflection line x equals to 0. Let's go and draw in our line x is 0. Well, the x-axis, again, is this one here. And it's going to be going through the point 0. So actually, it's going to be this line here. So kind of like working in reverse, right? We're kind of saying, well, we're now at B, the final one, going backwards. If we go and do this one first, so we reflect shape B along that line there. So again, choose a point, count in 1 square, so then 1 square across again, and we plot that point to begin with. We then choose another point, so like here, and we're going 1, 2, 3 squares across, so 1, 2, 3 squares across. Good, there we go. And then finally, we've got this point down here, 1, 2, 3 squares, 1, 2, 3. We plot that one in, there we go. And we go and join our points together, like that. Oh, that's not very neat. There we go, and there we go. So I've sort of done that first one there. So I'm saying, right, how do I get from shape A, which is here, to this shape here. Well, again, go through your transformations. Could it be a translation? No, because that's like moving up or down and the shape will stay the same. Is it an enlargement? No. Is it going to be a reflection? No, because it just looks a little bit awkward. This one's actually going to be another rotation. Okay, and yeah, to get from this one to this one, again, you need some tracing paper, which I can't do on the screen. Okay, so you just kind of got to imagine it, that we can do it, and we can write it up together here. This one's actually going to be, to get from A to the red shape, it's going to be a rotation. So you get 1 mark for saying rotation. And it is about the center. So you'd have to actually put the paper on the center 0, 0. So right at the origin, which is one that they like to go for in exams. And the angle of rotation is 90 degrees anti-clockwise. So sorry, I didn't mean to do that. Anti-clockwise. Or you could say 270 degrees clockwise. Okay, and that is it. Rotation, you've given the coordinate, you've given the angle and the direction. That is it for all the marks. Apologies, I can't show. I can't find out how to get the rotation, the tracing paper on the screen here. But hopefully you get the idea, right? So what we're really saying is, we have shape A here, and then if we transform it by doing a rotation about the center 0, 0. So literally, I've rotated the shape with tracing paper about that point there. Okay, 90 degrees anti-clockwise, I would get from this shape here to this red shape over here. And then I reflect the red shape along the line x is equal to 0, which I really should have written it again. X is equal to 0. I get to my final shape here, which is B. Okay, hopefully that was useful. And that is it for shape transformations. We'll look at negative enlargements on the next video. Okay, thank you.